Good day everyone! We are electronics engineering students from Quezon City University. Today we are going to discuss Boolean Algebra through this informative video presentation. But before anything else, let us introduce ourselves first. Representing Group 3 from SBEHEA, my name is Raymund Alfred Aningat.
I am Aquino.
I am Erick Hernandez.
I am James Eresuelo.
I am Christian Joseph Galwan.
And I am Hidacan.
So guys, what are you waiting for? Sit back, relax, and enjoy as we dig deeper into our Boolean Algebra journey.
So without further ado, let's now talk about the history of logic circuits and Boolean algebra. Primarily, Gottfried Leibniz refined the idea of a binary system. He also proposed that one can also combine arithmetic and logical principles using the binary number system in 1705. Later, in the year 1854, George Boole discovered the concept of Boolean algebra, that does the consistent way of comparing numbers to construct decisions. Then published his work in the book titled An Investigation of the Laws of Thought, on which are founded the mathematical theories of logic and probabilities. He wished to showcase how mathematical form can represent human reasoning. Later, in 1886, the concept of logical operation in the electrical switching circuit was described by Charles Peirce. In the meantime, Fleming bulb got used as logic gates, and relays got replaced by vacuum tubes in 1907. In 1954, Walter Bock got the Nobel Prize in the field of physics for the invention of the first modern electronic A&D gate in the year 1924. Claude Shannon then cited the notion of Boolean algebra in 1937 for the design of switching circuits. Still, research and analysis prevail for the development of molecular logic gates. Boolean algebra is a division of mathematics that deals with the operations on logical values and incorporates binary variables. Boolean algebra traces its origins on an 1854 book by mathematician George Boole. Its distinguishing factor is that it deals only with the study of binary variables. Boolean variables are represented by the possible values of 1, true, or 0, false. Variables can also have more complex interpretations. Boolean algebra is also known as binary algebra.
I will discuss to you the postulates and theorem of Boolean algebra. This is important because we will use this later in simplifying and minimizing Boolean functions. First are the simple Boolean postulate and theorems. We can verify this easily by substituting Boolean variables with 0 or 1. Postulate 2a, x plus 0 is equals to x. Postulate 2b, x times 1 is equals to x. Postulate 5a, x plus x prime is equals to 1. Postulate 5b, x times x prime is equals to 0. Theorem 1a, x plus x is equals to x. Theorem 1b, x times x is equals to x. Theorem 2a, x plus 1 is equals to 1. Theorem 2b, x times 0 is equals to 0. Theorem 3, involution, x prime prime is equals to x. Postulate 3, commutative, x plus y is the same as y plus x. X times y is equals to y times x. Theorem 4, associative, x plus the quantity y plus z is equals to x plus y quantity plus z. X the quantity y times z is equals to x times y quantity z. Postulate 4, distributive, it permits multiplying or factoring out an expression. A, x times the quantity y plus z is equals to xy plus xz. B, x plus y times z is equals to the quantity x plus y times the quantity x plus z. Theorem 5, De Morgan. In this theorem, two separate terms is the same as the two terms inverted. X plus y the quantity prime is equals to x prime y prime. Xy quantity prime is equals to x prime plus y prime. Theorem 6, absorption, x plus xy is equals to x. X times the quantity x plus y is equals to x.
So here are some example problems of Boolean algebra. In this sample problem, what we need to do is to prove that a prime bc plus ac is equal to c quantity a plus b. And in order to do that, we just have to simplify. And ang technique dito, ang isi-simplify natin is yung longer term or yung mas komplikadong term, which is yung a prime bc plus ac. Para mapadali yung pag-simplify natin, we need to be familiar dun sa postulates and theorems of Boolean Algebra. Because ito yung magsisilbing guide natin sa pagsisimplify. In this case, makikita natin na meron tayong common variable dun sa dalawang term, which is yung variable c. Based dun sa table, or dun sa postulate for distributive property, pwede nating ilabas yung c. So yung equation natin is magiging c quantity a plus a prime b. Next step, postulate for distributive property pa rin. Pwede nating i-distribute yung a dun sa a prime b. So now we will have quantity a plus a prime, quantity a plus b, both multiplied by c. Now that we're here, hahanap naman tayo ulit ngayon, pwede natin i-simplify. Makikita natin dito, isa sa pinakamadali, yung a plus a prime. Pag tinignan natin sa table, check natin yung postulate 5, x plus x prime is equal to 1. So we can say that a plus a prime is equal to 1. So since 1 na siya, pwede na natin siyang tanggalin. Kasi 1 times a plus b is equal to a plus b. And now we have c quantity a plus b is equal to c quantity a plus b. We already proved that a prime bc plus ac is equal to c quantity a plus b.
Here's an example. We have to prove that xy plus x prime y z prime plus yz is equals to y. So here we can simplify the second part. It will become xy plus y times z plus z prime x prime is equals to y. We have a rule here to postulate for distributive. We can see in the second part that we can simplify it more. It will become xy plus y, z plus x prime is equals to y. Then, the next step is, we're going to distribute the y. It will become xy plus yz plus y prime, x prime is equals to y. So we have to look at these two, the xy and the yx prime. We can factor it out if we take the y. It will become y times x plus x prime plus yz is equals to y. We have a rule, the postulate 5, which is x plus x prime is equals to 1. So we can simplify it to y plus yz is equals to y. Or to simplify it more, y plus 1 plus z is equals to y. As we can see here, we can apply the theorem 2. It says that 1 plus x is equals to 1. So as we can see, we can simplify it. So our answer is y. We can prove that this equation is equals to y.
For the next example, we have to prove that ABC plus ABC prime plus A prime B is equals to B. So meron tayong tatlong variables na may tatlong terms and dalawang arithmetic operations, which is addition and multiplication. Since common yung AB, pwede natin siyang ilabas. Ngayon, we have AB times C plus C prime plus A prime B is equals to B. Itong C plus C prime is equals to 1. Ngayon, ang lalabas dyan ay AB plus A prime B is equals to B. At meron na naman tayong common na B. Kaya ilalabas ulit natin yung B. So magiging B times A plus A prime is equals to B. Eh alam naman natin na ang A plus A prime is equals to 1. So therefore, equal pala silang dalawa, which is B is equals to B.
Prove that xy prime plus z times x plus y prime times z is equals to y times z xz. First, you need to distribute the z. It will become xy prime plus z times xz plus y prime z. Now, we're gonna use the FOIL method. xy prime xz plus xy prime y prime z plus zxz plus zy prime z. Remember that we have a rule, that theorem 1b, which is x times x equals to x. But if you see it twice, you only write it once, and it will become xy prime z plus xy prime z plus zx prime. We also have another rule that if we add the same thing, theorem 1a, which is x plus x equals to x, it will become xy prime z plus xz plus y prime z. Now, let's look at the y prime z, so we factor it out. Y prime times x plus 1 plus xz, then the x plus 1 applies the theorem 1, so it will become y prime z is xz, and it is the sum of the product. And if you're looking for the product of the sum, you need to factor out the z. So the answer of the product of the sum is z times x plus y.
And that's it. Finally, we have reached the end of our Boolean Algebra discussion. We hope you learned something from our video presentation, and please give us a like to support our group in our midterm project. Once again, we are Group 3 from SBEEGA. Thank you all for watching.